Hey everybody, Rusty here, and today I want to talk about a simple but effective way to crash proof your planes, at least your small microplanes anyways. And what I'm going to show you is, first of all, a few things in the design that you can do to probably just about any plane you build within this platform. Is, first of all, I have the wing here. It's secured with one rubber band here and none in the back. The back is pinned, and the reason for that is in a nose down crash, this wing slides forward, pops out, and releases itself. It even releases itself off the rubber band, possibly, and it floats free on the struts. Now, it's going to take a lot to damage the struts after the wing's free. Now, speaking of the struts, what I did here, if you can see this, but I put Z-bends, zip ties with holes in them, in my struts. So now when I want to remove the wing with the struts, it's not too big of a deal. I just pop the Z-bends out here. If I can get that one there. Pull this one out, just like taking the control horn off, except it's the whole wing. And my struts are glued into the fuselage. Here you can see the wing. What I did, simple, just two barbecue skewers right through that. Crash, it slides forward. Speaking of crash, when you crash, you're usually going to hit something up front, like the nose here now. Normally you'll crumple this nose section right up in a crash. I mean, you're just going to hit the ground, nothing's going to squash, because all the energy is going right into this foam here, right into this section. And even at the strongest point, it's still, all the energy is concentrated in spots where there are stress risers, like this corner here, you know. So what I did, I don't know if you can see this, but inside here, I've got a carbon rod that runs directly as the motor mount, from the motor mount, 3mm carbon rod, all the way up into a monoblock, the same monoblock that the wing slot is, that the wing peg goes into. Now, just underneath the wing peg, the wing slides in there on that peg. In a crash, you know, it'll pop out. But anyways, underneath there, that carbon fiber rod runs like this, right up through here into monoblock, and is glued into this monoblock here. And this monoblock is reinforced and glued. It's a 1-inch square of monoblock, 4 pieces in there sandwiched together and glued really well. And that spreads the load evenly all over this whole entire area. It takes all the crushing loads off the front of the plane, so the front of the airplane can't even crush anymore. It's actually going to pull down. If anything, it's going to take a lot to damage the airplane like that. Now back here, this over here, everything, most of the weight of the plane now is distributed evenly between the impact point. Because of this is the effective impact point right here. It impacts. The load gets transferred instantly through here. Nothing else is glued all the way through here. It's only glued in here. That way all the impact gets transferred to the center of the airframe, where it's spread out evenly throughout the airframe instead of concentrated at the front of the airframe and dissipated as the airframe crumples. Now this way the airframe don't crumple. You can just nose it into the ground. You'll break your props. You'll break your motors. Before you really break the plane, you'll actually, the worst thing that's going to happen is this carbon fiber rod's going to come out. That's going to absorb most of the energy anyways when it comes out. The plane's going to nose in a little bit. It might ding the foam a little bit up here, but it's not going to do too much. It's really a really good system, and it takes apart, goes together easy. I've just got one barbecue skewer that goes through here. Now, a barbecue skewer is not strong enough to use for this central rod here, this central load-bearing rod, because it'll just snap, and your fuselage is just going to crumple anyway after your rod snaps, after your skewer snaps. So what you want to do, make sure you have a carbon rod. I'd suggest about a 40mm carbon rod works great for these 180 size. This is a beast motor with 5x3 prop, I believe, a 50-30. Yes, this is a 50-30. I used cocktail stirrers with Z-bends on them for struts. And that eliminates the need for a heavy spar. I don't have to spar this wing at all. It also makes it lighter and less likely to be damaged in a crash because there's no spar to break. The whole wing can just really flex and foam. And it's a simple wing to build, again, if you do break it. Now, like I said, this goes back together pretty easy as well, too. You gotta do is put the Z-beams in this way. We'll start with this one. Here. Let's see that. I'll put one in there. We'll get this other one here. Just kind of pop it in there like that. Wing struts are attached. Let's slide this pin. Your wing can never be off center with this. It's beautiful. Just slide it in there. Just keep the rubber band on here and just pull a couple of loops up. I got fat fingers, but I'll try this with my lefty. There we go. You pull a few loops up like that. And now if you crash, it's just going to stretch out and pull off, and it's not going to come off in flight. And there it is, and that's how you crash proof a plane. And if you do this to your planes, I bet you'd have a lot better success in not crunching the nose. You could really drive these things into the ground pretty good. And nothing happens. That carbon fiber rod takes up most of the stress. It flexes too. It takes up a lot of the stress in itself. And the rest of the stress is borne by a larger portion of the airframe and spread out more evenly throughout the airframe, with tension loads applied forward of the monoblock bulkhead point and compression loads applied after the monoblock bulkhead point, right at the point where the frame makes a good solid triangle, a good solid load-bearing structure. So the weakest point on the thing is probably the tail itself. If you hit the tail, you're going to break this little section here. It's not too strong, but for nose-in stuff, 90% of your crashes are going to be nose-in stuff for beginners, for messing around with 3-channel and just stall, spin, and pop, although this thing really don't stall spin too easily. But that's it. Thanks a lot. Oops. Go down there. Such a beautiful flying plane too. There it is, that's 3-channel plane, flying inverted. It was full out there, but who knows how many I lost track of in crashes. There we go. Thing just keeps on going no matter what. Love it. Approach is tricky. Tight. I cracked my wing good again that time. Oops. Nothing on the hot glue in the second can't fix though. There it is.